Hi everybody, this is Mrs. Mancuso and this is a lesson for the redox unit. We have been spending a lot of time working on oxidation half reactions, reduction half reactions, and figuring out if something is spontaneous or not. And now we're actually going to use that to figure out if it could create energy. This is a Voltaic cell in the picture, so what I want to show you is how it works. First of all, you've got to notice that there are two separate chambers. In one of the chambers, we'll have oxidation, and in the other chamber, we will have reduction. So we're going to start out over here, and I'm going to pick two metals. I'm going to say that this metal strip, so this is a piece of metal, this is, you can picture it like a beaker, and there is an ion solution. This is called a salt bridge. We'll talk about it later. And then over here's another beaker, so a separate container, and I want another metal over here. We'll say that this metal is copper. These two metals are connected by a wire, and the wire has a voltmeter. There would actually, you can set something up to read the voltage that's going through. So when electricity goes through a wire, it's really electrons going through a wire, and you can measure the amount of power that is possible from that. So first thing I want to notice is that aluminum is higher on table J than copper. The one that is higher will be oxidized. So this, where oxidation occurs, is called your anode. So anox. So this whole piece of metal here is my anode, and that's where oxidation is going to happen. So I just want to focus on this oxidation half reaction right now. If you look up aluminum, it will become aluminum ions. So these actual atoms will break off. So here they are, all of these atoms can actually break off and form ions, Al+3 ions. So I'm literally writing the half reaction when I draw the arrow and I write the ion that it forms here. And you'll know that oxidation is losing electrons, and to go from a 0 to a +3, it lost 3 electrons. So up here in the wire, I need to show that the electrons would move this way. Now, over on this side, this is where reduction is occurring. And you'll remember reduction is gaining electrons, so the electrons go here to the copper. Over here, since this is reduction, this is called our cathode. The cathode is the electrode where reduction happens. So we have our anox and we have our red cat. That's a way of remembering it. Over here, I want to draw the arrows showing the reduction that occurs. Cu is a +2, and it's going to form atoms. So this is actually going to grow and increase in mass. The electrons come down from here, and if you take Cu+2 and you add the electrons to it, you will come out and form copper atoms. So I like to say that the red cat gets fat. This is actually growing, whereas over here, this one will decrease in size. It will weather away because the atoms are breaking off and forming ions in the solution. So underneath, I want to write my half reactions. Al became Al+3 plus 3 electrons. And this was oxidation. Over here, this half cell is reduction. Cu+2 plus 2 electrons became Cu. And lastly, I would like to write a balanced skeletal reaction. So I'm going to switch colors here because I need to do some balancing. I've got 3 electrons here and 2 electrons here. I want to go to 6. So to change that to a 6, I would have to double this and double this. And to have this one go to 6, I would have to triple to have that to go to 6 and triple. So my balanced skeletal reaction would be 2 aluminums plus 3 copper 2 plus ions forms 2 Al plus 3s plus 3 copper. There it is. I have a total of 6 charges on the left and 6 charges positive on the right. So the charges are equal. 2 aluminums, 3 coppers, 3 coppers. So I figured out the oxidation. I figured out the reduction. I have a balanced skeletal reaction. If I go back to my drawing, I have a spontaneous reaction occurring because aluminum is higher on table J and it's being oxidized. So I just want to remind myself, this is the one that was higher on table J. The electrons move through the wire, and I drew arrows to show the electron movement. The last thing I need to identify here, this is my salt bridge. And the purpose of a salt bridge is to transfer ions. You'll notice in this picture on the reduction side, the copper ions are being used, so you have to keep adding positive ions to this side or you will run out. And over here, you're forming positive ions. And if you have too many and you don't move some, it actually stops working when you have a buildup of too many positives or too many negatives on one side. So this allows the transfer of ions back and forth between the two containers. All right, let's practice. Let's keep doing more and more of these. So this time, let's pick nickel, Ni, and let's pick titanium. Nickel and titanium. I'm really just picking any 2 metals, and now I got to go over to table J and I got to see which one is higher. So nickel's pretty low, so since this one is lower, this side is going to be my red cat. So reduction is going to happen over here. This is my cathode, and over here is going to be my anox. So this is where oxidation is occurring. So this one is going to lose electrons. So if it loses electrons, it forms Ti plus 2 ions. And then over here, I want to show the electrons going through the wire. So the electrons would go this direction. Just so happens that this time when I drew it, it's on the opposite side. This time I have the cathode over here and the anode over here. All right, now I want to show that the nickel is actually going to form atoms. So I want to have Ni plus 2 ions gaining the electrons that are coming down through the wire and forming more atoms. This side will gain in mass. I like to say the red cat gets fat. So this side's going to get bigger. This side is going to get smaller as it wears away. All right, if I write out my half reactions, this is reduction. So Ni plus 2 electrons forms Ni. And over here, my oxidation, Ti, becomes Ti plus 2 plus 2 electrons. And then I want to write my balanced skeletal reaction. And the electrons are actually already balanced, so that makes it a little bit easier. So I just write Ni, which is a plus 2, plus titanium, becomes nickel plus Ti plus 2. All right, let's see if there's anything else that we can draw on here. All right, there is something else. An anode is a negative electrode. So I'm going to put a negative sign here to show that the anode is negative. Electrons are negative, so they leave the negative and they go to the positive side. The cathode is the positive side. And if I write out the word cathode instead of just writing red cat, you'll notice there's a T in it, which reminds you that that is positive. The electrons would always go towards a positive too, naturally. And this, again, is where my ions can move back and forth between the solutions so they don't polarize. All right, let's try another one. This time, let's try silver silver's Ag, and magnesium, Mg. All right, I look them up, and Ag is really low, so this is going to be my reduction, and that means it's going to be my red cat, so this is my cathode. That T reminds me that this is the positive side. Magnesium is higher, so that's going to be my anode. This is where oxidation is occurring. Anodes are negative. So now I need to write my reactions. Ag is going to form atoms. And Ag plus 1 is in the solution, and it's going to form more silver atoms here. So this side is going to gain in mass. Over here, this one's losing, and it's going to become Mg plus 2 ions. As it loses, it also loses electrons, so I need to show the electrons moving through the wire in this direction. So these are my electrons, and they are gained over here by the cathode. I have ions that can be transferred back and forth through the salt bridge. All right, down at the bottom, this is my reduction. I have Ag plus 1 electron forming silver. And over here on the oxidation side, I have Mg becomes Mg plus 2 electrons. And now I want to practice writing that balanced skeletal reaction. So I'm going to get a new color here. I've got 1 electron gained and 2 electrons lost. To balance that, I want to double this whole side. So I'm going to need 2 silver ions forming 2 silvers. Now I have 2 electrons, 2 electrons. So to write my balanced skeletal reaction, 2 silver ions plus magnesium forms 2 silver atoms plus magnesium with a plus 2 charge. And if I check my work, 2 silver atoms, 1 magnesium, 1 magnesium. A charge of 2 times a positive 1 gives me a positive 2 charge, and that's equal to over here 1 atom at a positive 2 charge. So I know everything is balanced. I go up and I check my work. I've labeled my cathode. I labeled where reduction occurs. I labeled my anode, and I labeled that that's where oxidation occurs. I wrote my half reactions. I'm showing that this side is losing mass and this side is gaining mass. I have my ions moving through the salt bridge. I have the positive and negative electrodes indicated, and I've shown where electrons have moved through the wire. These are all the steps that you need to include, and I want you to go through all of the practice problems. I want you to do the work on your own. You can ask a partner if you want to check your partner and see if you guys are getting the same answers. My keys are available, and I want you to keep practicing until you feel confident, and then I have Castle Learning for you to try as well.